Welcome back to geometry. We want to continue taking a look in section 20. So we want to take a look at arcs again, but we're going to take a look at the theorems related to arcs. Now, much like angles, angle measures, and distances, we can add distances and add angle measures, and here we can add arc measurements as well, right? So we want to recognize that if we have two adjacent arcs, then the sum of their measures gives us the measure of the arc ABC. So if we have one arc and another arc, call it A, B, C, with, let's see here, P and Q on here, then this arc measurement plus this arc measurement gives us the arc measurement of the entire thing together, right, when they are adjacent. Excellent. So to prove this theorem, it's not difficult, but it's tedious. Tedious in that there are many cases to the theorem. In proving it, you want to use the angle addition postulate, the supplement postulate, and the definition of arc measure, right? It works out very nicely because when we have adjacent arcs, we have adjacent angles that we can refer to for that measurement. So that, that should work out very nicely. And in the homework, you are only asked to take a look at case number 2. The others we're not going to worry about. All right. So a couple of definitions for us. An inscribed angle and an intercepted arc. All right. An inscribed angle is an angle whose vertex is on the circle and whose sides intersect the circle. Excellent. So in this case, what we're looking at is if we have a circle, we just need a vertex that is on the circle and then two sides that intersect the circle. So this is an inscribed angle. Let's see here. An intercepted arc, okay, may be defined as an arc of a circle that lies in the interior of an angle whose endpoints lie on the sides of the angles. This is an intercepted arc of the angle. So there's a lot of different ways that we can encounter an intercepted arc, and we don't have to have an inscribed angle to find an intercepted arc. We have 4 different diagrams down here demonstrating how we might encounter intercepted arcs. So for example, this one does in fact have an inscribed angle. Like the B is on the circle, so this angle is an inscribed angle, and the intercepted arc is APC, okay, intercepted arc. But we could have different placements of the vertex, and we could have different situations for the sides of the angle as well. So start with our vertex inside the circle. If we look at our vertex inside the circle, then we have angle measure, right? Or we have our angle, and the intercepted arc is the arc of the set of points on the circle between the intersections of the angle and the circle. Okay, intersection, intersection, it's the points in between that are in the interior of the angle. Okay. Another situation we could have is that we have that the vertex is on the circle like it was over here. However, we actually have that this line is tangent. And in this case, we still consider this a point of intersection and this a point of intersection, and then we're looking at this here. All right. And then one more situation, of course, we could have be our vertex on the outside of the circle. And in this case, right, we are looking at the same way that we've been doing it. We look at the intersection, and everything in between gives us the intercepted arc. But in this case, there's actually two pairs of intersections. So there's one pair and here's another pair. So we actually have two intercepted arcs in that first example there. So those are the four ways that we can encounter it. Now, the main thing that one situation that you might think to yourself should exist as well is if we have the angle vertex outside of, and we have this. Now, we don't consider this situation because, right, the fact that it's an angle doesn't matter at all. This line right here, that guy doesn't matter. So we've got, it's the same thing as just considering a ray. So it would not be we wouldn't have an intercepted arc because we don't really have an angle. Yeah, we happen to have this other line, but it doesn't play any role. So, we would take a look at, we wouldn't take a look at that situation. That's not what we're concerned with. Anyway, so these four situations are what we want to think of when we think of an intercepted arc. All right. Now, the last thing that I'd like to take a look at in this video is the computer exploration. And just very briefly, you can read this yourself. So I'll make sure that the exploration gets posted because you're going to want to utilize GeoGebra again. And what I'd like to do is I'd like to leave it to you to complete this exploration and to finish the section. So as it states here, there are many relationships between the measure of an angle and the arcs that it intercepts. So we want to use GeoGebra to investigate these relationships. And these relationships are described in the following collection of theorems. I believe there are 6 theorems here. So 2018, 19, 20, 21, 22, 23, and 24. So that's actually 7 different theorems. So you'll notice that most of them have a missing conclusion. Okay. That one is a corollary there. So not just theorems, but corollaries. Yep. Let's see, all have missing conclusions. Excellent. So what you want to do is you want to consider the collection of circles and angles that are given in this file and consider each of the situations below. So read through these, follow the directions, and try to, as it asks you to do, fill in the conclusions to the following theorems. It looks like there's one of them, 20.19, that it doesn't necessarily ask you to fill in, and then fill in for all of the remaining. So 18, 19, not so much, 20, 21, 22, 23, and 24. Excellent. So I suppose really quickly, I'll give you what you need to fill in for 19, and actually this one, it's pretty obvious anyway from the diagram that's given, but if A, B, C is inscribed in the circle, then AC is a diameter if and only if this is a right angle. So the measure of angle B is equal to 90 degrees. which of course you could investigate that as well. But the rest of these I will leave for you to consider and work through. And if you have any questions, feel free to ask. If you want to double check your conclusions, we can do that. Just let me know and we can talk about it. So thank you for your time and your attention, but that is all that I wanted to share with you today. And for us, we'll call that the end of section 20. There are some proofs to fill in that are in this last little bit that I'm leaving you to fill in. If you don't fill in those proofs, that's okay. The main thing is making sure that you can fill in the conclusions of each of those theorems and corollaries. So again, I can check those and we can talk about the proofs during lecture if you would like to. You guys have a great day. I'll see you soon.